Hello, today we'll be talking about a data structure called tries. You will learn what tries are and also learn about how they specifically work. Like always, I'll be explaining basic concepts first with diagrams and stuff, and then after that we will go and do some coding. Okay, so let's dive in. A trie is a tree structure which is mostly used for storing words. Each node will represent a word or part of a word, and by connecting the path from the root to that node, we can store words in this particular structure. We do this because it lets us search words pretty fast. One application for tries is autocomplete. You know how when you're searching something in Google, and as we type in a search word in the search bar, Google tries to guess what we're trying to type. And the more letters we type in, the more closer it guesses. And tries can also use this to suggest what the next word would be. Look at this trie over here. The trie is currently holding the words Aragorn, Aragog, Aragon, Aragon, Oregon, Oregano, and Oreo. Tries will have a root node at the top, which will have children nodes, one for each possible alphabet. There are 26 letters in the alphabet, so each node will have 26 children nodes. Just to keep it simple in this diagram, I didn't draw all the empty nodes, but if you actually look into each node, it will have an array where each index will represent all the possible characters in the alphabet. And the ones that represent the children will have a pointer inside it that points to that child node. For example, let's look into this node that holds the R in Aragorn and Aragog. This node will have an array with a size of 26. And the indices will be all nil except for the ones that represent A and G. Each node needs to hold this array containing the addresses of the next nodes. But it also needs another piece of information. The nodes need to have a Boolean value indicating whether the node is an end of a word or not. For example, in the word Oreo, ORE will have false as a value for the isEnd value, but the last node of Oreo with the letter O will have true as the value, indicating that that is the last letter of the word. If we set the isEnd value of the R node in Oreo, we would be adding the word or in the list, and or would be stored in the trie along with the others. Now that we know the basic structure of tries, let's see how we can insert and search words inside a trie. Let's say we want to add a new word, orc. First, we start at the root and look into the array that holds the address of the children. Then we'll see if there is something in the index that represents the first letter of orc, which is O. So yes, it has it. There is a pointer at that index that points to the child node for O. So let's go to that node. This is also a node just like the other nodes, like the root nodes or any other node. So it will also have an array that holds the pointers of the children. And this time we'll see if there is something in R, because that's the second letter in orc. And yes, there is. So which means we have a node for that. Same goes for the next node. We'll see if there is something in the index for C, which is the third letter of orc. So this is where we create a new node and add the address of the new node to the array index of C. But this is not the end. Because we finished adding the word orc, we need to set the isEnd value of the last node as true. Okay, so that's the end of inserting a word. Now that we successfully added the new word orc, let's go and try to search this word in the trie. The process is similar to inserting the node. Go to the root and just check if there is a match for the first letter. Then follow that pointer to get to the next node and check for the second letter R, which is there, and then to the next to search for the third letter C, which is also there. So we have O, R, and C in the trie. But there is one more last step. We need to check if the isEnd value of the last character C is true. If we try to search for a word that is not in the list, for example, orb, it will immediately let us know that the word is not there once it finds an empty index of the children array. Now let's talk a bit about the time complexity of a trie. The big O will indicate how fast and efficiently inserting or searching in a trie can be. Let's say the length of the keyword we're searching or inserting is M. In that case, the time complexity will be OM, because we will have to follow down the tree M times. However, this is not always the case. There can be a better scenario when we are searching the trie. If the search meets an empty spot for the next character, it would immediately stop the search and return false. So in that case, it would be better than OM. If we use tries, we can search words very fast, but usually a trie can take a lot of space. Think about each node has 26 children, and the required space will exponentially grow as we add longer and longer words into the trie. This is why tries are known to have a trade-off between time and space. Okay, so far we looked into what tries are and how they worked, and now let's go and try to implement that in code. Okay, so let's start coding, just the basics. And we're basically going to do three things here. The first one is to make the structure for the node and the tries. The second is to make an insert method, and the third is to make a search method. So let's just write that down here. We first need to make a struct for a node, and a struct for a trie, and also an insert method and a search method. Okay, these are the three things: making the structure for the node and trie, insert, and search. We are going to do these three things. So let's start with node. So like I explained before, the node first needs to hold an array, and the array is going to be a size of 26, which is the size of the alphabet, and each index of that array is going to hold a pointer pointing to the child. So we can call it children, and it's going to be size of 26, and it's going to be a pointer pointing to another node. But one thing about this is it's not a good idea to actually hard code the numbers inside here, so I'm going to make that into a constant, and I will call it alphabet size, and that is going to be 26. Because this is starting with a capital, that means that I'm going to use it somewhere else, so it's a good idea to actually just make a comment on explaining what it is. Okay, and before I explain that, the node needs another piece of information, which is indicating whether the node is an end of a word or not. So I'm going to make another variable, and that's going to be a Boolean value. Okay, so that is the structure of a node. This time I'm going to make a structure of a trie, and the trie is going to be very simple. It's just going to hold a pointer pointing to the root node of that trie. We'll call it a root, and that's just going to be a pointer pointing to the root node. Okay. So when I want to try to initiate a trie, I will first have to create this struct, and then I'll have to create a node, the first node that will become the root, and then make a node with this, and then appoint that to this trie. So I'm just going to make a function that can actually do that process. I will call it init trie, and there's no parameters, but it's going to return a pointer pointing to that trie that is created. So the return should be a pointer of a trie. And here I'm just going to go result. And first we need to create a trie. And inside that trie, we're going to appoint a root, and we're going to create a node that is going to become the root. Okay, so right now what we're doing is, Right now what we're doing is we're going to create this node, put that pointer as the root as we create a trie, and it's going to return the results here. So return result. Okay, and we need to put a comment here in it, try. I will create a new trie with a new trie. We just made the structure. We have a structure of a node and a trie and a function that can initiate a trie. Okay, so let's go and see if it works. I'm just going to make a very simple test trie, and I'm going to init. Okay, so this is going to initiate a trie, and I'm going to name that test trie. And I will just kind of print out the whole thing. Okay, so right now this is going to be the address of the trie that is created. We don't have that much information here. We don't we can't check if the node is created properly, so I'm just gonna say test trie.root to check if we have an empty node inside there. Just want to check if it's creating it properly. Oh, so yes, this is going to be what's inside the node, the root node, and right now you can see everything is set to default. All the values in the array is nil and false value for the isEnd. Okay, nice. All right, so the next step, we're going to do the insert method. It will add. Okay, so insert is going to take in a word, which is going to be w inside the function, and it's going to add it to the trie. So we're just going to implement what I explained before with the diagrams. We're just going to do exactly the same thing. The first step is to loop through w, which is the word I'm trying to add. Loop through the characters. If I'm going to add the word orc, I'll have to try to loop through O, R, and C and see if there's a match. And if there is no match, I'm going to add a node, create a node, and add it to that character. So first, I'm going to build a structure inside this method so that I can make a loop. So it's going to be for I starting from 0 to I smaller than the length of w and I plus plus. Okay, actually, I want to put this as a variable. I'm going to call it word length. And I'm going to go, okay. So we're going to travel from the root and compare it to the first letter of orc, and move to the next node and compare it to the second letter of orc. We have to do that process. So we want to have a variable that can indicate where the current node is, the one that we're at. So I'm going to express that as current node. And right now we have to start at the root, so that's going to be t.root. If the current node, and because it's a node, it's going to have children. And inside here, we need to put the index of the character of that children. So in that case, we need to change the characters into the index. If we're going to do insert orc, then this is going to be O, but we want to change it into the index. And we express that as this. So just to give you a better understanding of what's going on here, I'm going to bring this in. I'm going to print out that. And if you run it, you'll see that it's indicating 97. So for example, what I want is I want A to become 0 because it's the first letter of the alphabet. I want A to become 0. I want B to become 1, C to become 2. So in that case, what I need to do is So whatever I put in here, the char index is going to become this number over here. If I want to put O, then the index number 14 of the children array will represent the letter O. So that is why it's going to look like this. Right now I'm trying to change this character into the character index of the children array. So that's why I'm going to go like that. So as we follow along from ORC, we're trying to find where there is no match. There is nothing. There is an empty index representing the character. So we can express that as nil. And if it actually becomes nil, we're going to create a node and put it into that empty space. Create a node, get the pointer, and put it into that index. So we can say current node.children. So this is where it's nil. In that nil place, in that nil index, I am going to assign the pointer of a new node. So I just created a node and put it in there. So in that case, that created node is going to become a child of that current node. And for this for loop to work, after we finished each loop, we need to update it, right? Let's say there was a match and this if statement was all ignored. In that case, we need a line that can actually let the node go to the next. So in that case, we need to update the current node. Okay, so if that index is not empty, we're going to follow that index and we're going to put that into the current node, which is going to be the next node. Okay, this is not the end. After we added the last node, we have to indicate that that's the end of the word. So, and this has to come at the end of the insert method. Okay, so now we're going to do a search method. A search method is going to take in a word and return true if that word is included in the trie. So yes, this means that this function is going to be a method of the structure trie, and it's going to be called search. It's going to take in a word and it's going to return a Boolean value. Okay. The searching process is very similar to the inserting. When we don't find a match, instead of creating a new node and inserting it, we're just going to return false. So I think it's code-wise, it's easier than an insert. So I'm just going to copy and paste all the stuff that I wrote here and put it here and fix it a little bit. So I guess these parts we already went over it, so I don't have to explain that to you again. But here, instead of creating a new node and putting it into the current node, I am going to just return false. We just immediately know that that word is not in this trie, so we just immediately return false. We still need to update the for loop, so I'm going to leave this part. And this part over here needs to be turned into an if statement, saying that if it's true, then yes, we're going to return a true. Current node.isEnd is true, then we will return true. So the condition of returning true is first, it needs to successfully pass this for loop without returning a false, which means it needs to have a match for each node. And then it's able to return true when the last node, the isEnd value, is true of the last node. So right now the current node here is going to be the last node because we kept on updating it with this line over here. Okay, and at the end we're just going to return false in case the is end is not true. Even if we have like all the matches in the for loop, but this didn't come through, in that case, it's not the end of the word, so we're going to return a false. Okay. I forgot to put 2 equals there. So now we have the search method and the insert method. Let's go and write something in here so that we can test it out. So we have test try. Let's just change the word, change the and instead of that, I'm going to insert. Okay. So I'm just inserting one word, Aragorn, and searching it. So this one should actually return a true, which I'm going to print out. All right, okay. Oh, true, we got a true. So right now we inserted Aragorn and then we searched it, and it turns out that it is there. Like the video before, instead of actually like going like that, I'm just going to make it a bit more simple and use a for loop. Let's call it to add. That's going to be my slice. Okay, so right now I made a slice and named it to add and put all the words I want to add to the try. And then I made a for loop so it can insert all these words. After that, I'm going to try to search one of the words here, which let's search Argon. And let's see if that returns a true. Okay. Okay, so yes, it returns a true. Let's try to add something that's not there. Wizard. Okay, so false, it's not there. I hope you know more about tries now, and if this video was helpful and you want to see more of my videos, please subscribe to this channel, and thank you so much for watching and have a good day. I'll see you in the next video.